Now let's look at the next method. So the next method says that we must be able to solve these rational expressions using factorization method. So now, the direct substitution method is used when our g of x, so if we have the limit of a function, f of x over g of x, when this g of x now, whenever we apply the limit directly, when g of x is equal to 0, then we no longer use the direct substitution from the beginning. So we try now using the next method, which is the factorization method. Sometimes we use other methods, but we'll discuss those ones. So now if you look, in each of these cases, directly apply this limit 3. If you put 3 here, 3 minus 3 is 0, right? If you put negative 5 right here, negative 5 plus 5 is 0. If you put positive 2 here, positive 2, 2 squared is 4. 4 minus 2 is 2. 2 minus 2 is 0. If you put 3 here, the root of 3 minus the root of 3 is 0. If you put minus 3y over 2, you replace this x with minus 3y. So 2 and 2 will cancel, you'll be left with minus 3y. So minus 3y and plus 3y is 0, right? And the list goes on. Change of x, if you replace this thing with 0, it gives you 0. This one, if you replace this x with minus 1 plus 1 is 0, and the rest of them. So because we are experiencing 0 within the denominator when we directly apply the limit, we strive to simplify the limit such that that thing that is making the denominator to be 0 can be eliminated. So let's go about the solution of the problem. So now, we'll do the first problem. The first one says the limit of x squared minus 9 all over x minus 3 as x is approaching positive 3. Now, look at these things. The difference of two squares, x squared minus y squared, is just equals to x minus y times x plus y, remember from pre-calculus. Then x cubed minus y cubed is equals to x minus y times x squared plus xy plus y squared, right? Then the last one I want to look at, the sum of two cubes, x cubed plus y cubed is just equals to x plus y times x squared minus xy plus y squared. So let's keep an eye on those expressions. So whenever you have a two terms expression with a negative sign between them, you can think of how you can bring in difference of two squares. Now this first one is a square, and this second one, this is 9, right? So 9 can be rewritten as 3 squared. So now it has become difference of two squares. Remember now our x representing x here and our 3 representing y. So therefore we will have the factor as x minus 3, then x plus 3, right? Divided by x minus 3 as x is approaching positive 3. So what happens? X minus 3 and x minus 3 go out. You just left with the limit of x plus 3 as x is approaching positive 3. So when you directly apply the limit, now you have 3 plus 3 is equal to 6. So we got the first answer. Now all of these expressions in red that have been circled are all of the answers. So we'll solve some of them, the ones that we will not solve, you will practice it. Question 2. The limit of x squared minus 25 all over x plus 5 as x is approaching negative 5. So again, this is in the form of difference of two squares because there's a negative between them. And the first expression is square, so we can think of how we can make this one to be a base raised to a power of 2 that will give us 25. So we have x squared, we know that 5 raised to the power of 2 is 25, divided by x plus 5, as x is approaching minus 5. So what happens now, if we factorize it, you have the limit of x minus 5, which is the factorization, x plus 5, divided by x plus 5. So x plus 5 now will cancel. So what are we left with? We are just left with the limit of x minus 5 as x approaches minus 5. So now we replace, you have minus 5 is just equals to minus 10. We do the next one. Question 3 says the limit of x squared minus 3x plus 2 all over x squared minus x minus 2 as x is approaching positive 2. Now this is a quadratic expression, so we try to factorize it using the quadratic method, right? So we open our parentheses like this. We're factorizing both the numerator and the denominator as x is approaching positive 2. Now mind you now, this is very easy to factorize because the coefficient of the quadratic term here is just 1. So our target now is the first term and the last term. So we expand the first term, we have x and x, give us x squared, right? Then now we move to the last term. Which two numbers that are factors of these two that we can multiply to give us positive 2? If we add those same numbers, we will get minus 3 in the center. So we know that since this is positive 2 and this is minus, right? The last term is positive, so it means that the two expressions must be positive. When the last term is positive, the two expressions must be positive. So we have minus 2 times minus 1. Minus 2 times minus 1 will give us positive 2. But minus 2 plus minus 1 will give us negative 3. So we can say minus 2 and minus 1. Then down here, we expand the first one, x and x. Move to the last one. Which two numbers can we multiply to give us minus 2? If we add those same numbers, we will get a coefficient right here, which is minus 1. So we cannot say negative 2 times negative 1 again, right? So we change it. Now, because we have a negative within the center, which is attached to the middle term, the negative must be attached to the biggest number so that if you add these two numbers, your final answer will be in negative. So we take minus 2 and positive 1. Minus 2 and positive 1. So now we can just get rid of minus 2 and minus 2. So you see, this x minus 2, it is that factor that has been making this entire denominator to be equal to 0 when you apply the limit directly. So it is that factor now that we've been striving to get rid of, so that when we apply the limit directly, we cannot have a 0 within the denominator. But there will still be some cases that even if you simplify it, right, at a certain point in time and you apply the limit, you will still have 0 within the denominator. Those are special cases. So now we have the limit of x minus 1 divided by x plus 1 as x is approaching positive 2. So we can now test the limit in the denominator. If we put 2 here, 2 plus 1 is 3. So we can apply the limit now. So it's 2 minus 1 divided by 2 plus 1 is just equals to 1 all over 3. So we look here, our answer now is 1 over 3. Now, so we continue with question 4. Now, question 4 says the limit of x minus 3 divided by the root of x minus the root of 3. Now, this is one thing you need to know. Every two-term expression that has a negative sign between the two expressions are factorable. Every two-term expression with a negative between them are factorable. The only thing is that most of them are not factorable over real numbers, and some of them are also factorable over real numbers, but they are factorable, right? So now, let's look at this one now. Do you know that we can rewrite the numerator expression as the square root of x minus the square root of 3, all raised to the power of 2. Because if you say the square root of x raised to the power of 2, the square root can cancel, it just equals to x. The square root of 3 raised to the power of 2 is also equal to x. So we have not changed anything, we just rewrite the problem. Divided by the root of x minus the root of 3. So in this case now, our y is the root of x, and let's say our x is the root of x, and our y is now the root of 3. So we can now factorize. So this now gives us the root of x minus the root of y, that's the root of 3, times the root of x plus the root of 3, all divided by the root of x minus the root of 3 as x approaches 3. So we could not directly apply, because if we directly apply, you will get 0 down here. So the root of x minus the root of 3 can carry the root of x minus the root of 3. So this now just gives us the root of x plus the root of 3 as x approaches 3. Now what happens? You replace it now, right? So you have the root of 3 plus the root of 3. Now when you are adding radicals that have the same radicands, it's just like you are adding variables that are the same, right? So you add their coefficient. So you have 1x plus 1x will give you 2x, right? The same way, 1 the root of 3 plus 1 the root of 3, it will just give you 2 the root of 3. So it was how we got this answer, 2 the root of 3. We'll do the next one. So the next one says, question 5, the limit of 8x cubed plus 27y cubed divided by 2x plus 3y as x is approaching negative 3y over 2. Now, you look here, if you directly replace this x now with your minus 3y over 2, let's try it. You replace this x with minus 3y all over 2. You observe that this 2 and this 2 will cancel, right? And then you have plus 3y. So minus 3y plus 3y is just give us 0. So we want to avoid 0 within the denominator. So because of that, we say let's see how best we can factorize the expression so that this denominator that is making this thing to be 0, when we apply the limit directly, it can be eliminated. Now, we have cubic expression in the numerator, and we have cubic expressions, let's say, both terms are in the form of cube, both of them, right? Now, so we think of the sum of two cubes because there's a plus between the two of them. So let's see as to whether we can rewrite these two. So if we rewrite these two, we will have 2 raised to the third power, right? Is equals to 8. And then x raised to the third power also is equals to 8. Plus this 27, 3 raised to the third power is equals to 27. And y raised to the third power is also 27. Divided by 2x plus 3y. As x is approaching minus 3y all over 2. So we can further simplify it. Now because the base here and this base, these two bases, right, they have the same power. We don't need to rewrite 3 raised to the third power, then x raised to the third power, repeating the power. No. We just say 2x all raised to the third power. Plus, we can now say 3y all raised to the third power. Right? Because power to power rule, the power here is 1, the power here is 1. You just say 1 times 3 is 3, so it will be s cubed. 1 times 3 is also 3, so it will be 2 to the third power. It's still the same. Divided by 2x plus 3y. As x is approaching minus 3y all over 2. So now we see how best we can factorize the numerator expression. Now, if we look at this numerator expression, it's just in the form of x cubed plus y cubed. So this whole thing in here is representing our x and this is representing our y. So therefore, we can factorize it like this one, right? So x cubed plus y cubed equals to x plus y. What is our x now? Our x is 2x. So you have 2x plus our y now is 3y times x squared. So the first term is x. So you have 2x all squared minus xy. This is x, this is y. So it's 2x times 3y plus y squared. This whole thing is y now. So it's 3y all squared divided by 2x plus 3y. As x is approaching negative 3y all over 2. Now we have factorized the numerator. So what do we observe? This one, carry this one out. We're now left with the limit of, now 2x to the second power means 2x times 2x, right? So it just gives us 4x squared. Now we have the next one. 2 times 3 is now 6. X times y is just xy. Then 3y times 3y is 9y squared. As x now is approaching minus 3y all over 2. Now because there is no denominator now that will make this thing to be 0, we can now apply the limit. So wherever we see x, we replace it with minus 3y over 2. So it's 4 minus 3y over 2 all squared. Minus 6 times x now is minus 3y over 2 times y plus 9y squared. So let's come up here. So we have, this is 4 now. In there, we multiply in there, it means we're going to do that 2 times. It's like this, 3y over 2. So multiply 2 times. So it's like 3 times 3 is 9. Y times y is y squared. 2 times 2 is 4. Negative times negative is positive. Then this 4 outside. So this 4 and this 4 will cancel, right? Move to the next term, you have 6 and 2. You can reduce it. 2 into itself 1 times, 2 into 6 3 times. So negative times negative is also positive. Then you have 3 times 3 now is 9. And this is just y, right? But this y times the other y outside is y squared. Plus 9y squared. So 9 plus 9 is 18, right? It's 18. Then you just bring the y squared down. So now you have 9y squared plus 18y squared. So 9 plus 18y squared now will just give us, is there any negative there? Okay, so 9 plus 18y squared now will give us, what is it? You add this to this one, now you have 20, you got 27y squared. So this answer should be 27y squared. Should be read. Just writing fast and then it slipped. So there's 27y squared as our final answer. Now, so let's do question number 6. And then we'll do the last 2. We'll just do the last 2 and then the rest of them now will be left for you to practice. So question 6 says, the limit of x plus changing x raised to the second power minus x squared divided by changing x. Now, we were asked to factorize this thing. Now, just look at now, right? If you just replace this thing in here with, say, let this be arrow. So you have arrow squared minus x squared, right? So now you can factorize this thing as arrow minus x times arrow plus x. Now let me put it on the side. arrow squared minus x squared, and then you can factorize it as arrow minus x times arrow plus x. You see that? But let's go directly. Now, if we want to factorize this thing, this entire first expression, remember now, is representing our x, because this is x raised to the second power minus y raised to the second power, right? This is not actually y, but it's represented, it's in the position of y. So now, because it is x raised to the second power and minus y raised to the second power, so this is in the form of difference of two squared, or minus sign between them. The first term is squared, the second term is squared. So based upon that, we can bring in the factor, which is x minus y. But what will be our x? Our x will be x plus changing x. This whole thing is our x. So we have x plus changing x. Then minus y. What will be our y? Our y is x, right? Minus x. So you see it? You see this one? Arrow minus x. This arrow minus x. So we finish factorizing the first one, we move to the second one now. You have, again, the same thing, x, which is now x plus changing x, plus y. Y is just x. Divided by changing x, as changing x is now approaching 0. So what happens? You have this and this going out. So we just have the limit of changing x times x plus x now is 2x plus changing x divided by changing x, as changing x is now approaching 0. So what happens? Changing x and changing x also go out. So this expression that was making the denominator to be 0 and to make this entire rational function to be undefined, they have now been eliminated. So we can now apply the limit. Changing x now is approaching 0. So this now, if you apply the limit, you have 2x plus 0 is just equals to 2x. Right? Now, what if we were not told to use the factorization method? What if we just saw this problem and decided to expand so that we can get our answer? Right? So let's do the expansion method. Let's expand. So if we were to just see this problem and start solving, right? Then we expand this thing. This is x plus changing x raised to the second power. So it's x plus changing x now raised to the second power, which is x plus changing x times x plus changing x minus x to the second power divided by changing x, as changing x is now approaching 0. So we can apply the forward method. So we have the limit, we multiply the first term, x times x is now x squared, x times changing x. Now, you don't say x times x is x squared, right? That is x plus x times changing x. Is that, you are not going to say x times x is x squared. No. You're just going to say x, and then you write the changing x beside it. Then the next one, changing x times x. So again, it is x changing x. Then changing x times changing x now will give us change in x all squared minus the x squared at the end divided by changing x, as changing x is now approaching 0. So what do you observe? The first term cancels the last term. So the rest of the terms now have changing x, right? So we can factor out changing x. So if changing x now is being factored out, in this expression now you will just have x. In this other expression you will just have x plus this one now you will just have one changing x, right? Because one is already out. Then you have, okay, this one is already out. So divided by changing x, as changing x now is approaching 0. So what happens? This changing x and this changing x go out. So therefore we will have the limit x plus x now is 2x plus changing x, as changing x now is approaching 0. We can now apply the limit. So we replace this one with 0, we just have 2x plus 0, which is just equals to 2x. So you see, the same answer we got initially. Now let's do the next one, right? What if we were asked to find the limit of this rational expression? But then, in one case, we're asked to use factorization method. In another case, we're not told whether to use factorization or not to use factorization. So we're going to solve it two ways. Let's do the first one. What if we're told to use factorization method? Now, if we look at this problem, we can clearly see that the numerator term is, the first term is cubed, and the second term is just 1, right? But you know that this 1 can also be raised to the 10th power. When 1 is raised to the 10th power, it's the same as 1. So it would now be x cubed plus y cubed, which is x cubed plus 1 cubed. So our 1 now will be representing y. So therefore, we can now factorize this numerator as x plus y, now we put 1, times x squared, minus xy, x times 1, plus y squared, we just say 1 squared. All divided by, this is x plus 1, as x is approaching minus 1. So this x plus 1 and x plus 1 will go out. Now you have the limit of x squared minus x plus 1, as x is approaching minus 1. So we do not have any denominator down here now that when we apply the limit, we're going to get 0 within the denominator. That makes the problem to be undefined. So we can now just apply the limit. So all of these these methods we are using at the end, after simplifying, they are all the direct substitution method. So now this is the direct substitution method. Now let's apply the limit. You have minus 1 raised to the second power, minus 1 again, plus 1. So what happens? You have minus 1 times minus 1 is just positive 1. Negative times negative is positive, and then plus 1. So 1 plus 1 plus 1 is just equals to 3. So it was how we got, was it 3 we got? Yeah, this was 3. This should have been 3. The answer is 3, then not. Okay, so to prove it further, let's do the next method. Let's say we do not want to use this method. Let's say we want to use long division. Let's assume you were asked to use long division to solve this problem. Long division is just like the way in elementary days, if they gave you, they say 4 divided by 2, right? Divide. So you say 2 outside and then the 4 inside. This is the long division. That's the long division. So now, since we are to divide polynomial expression, it's a little bit different from dividing numbers. So let's look there. Now this is a divisor, right? So we have x plus 1, and then inside now we have the dividend, which is x cubed. But this x cubed, the next term should be x squared. So we put 0 x squared. The next term should be x, but because it is not there, we replace it with 0x, plus the next term now should be a number, which is just a 1. So this is the first term here, which is now x cubed, and the last term is 1. Now, to do long division, this is the process. Our focus is the first term in the divisor and the first term in the dividend. So you say x go into x cubed, meaning x now, when it is entering into this x cubed, what will be our remainder? Meaning x cubed now divided by x, which is also the same as x times x, right? So divided by x and x will cancel. You'll be left with what? X times x is x squared. Now, since you are left with x squared, you cannot put the x squared on top here because it is cubed. You cannot put the x squared here because it is the constant. You cannot put x squared on top of this one because it is raised to the first power. So you look for the partner, right? The same power. So you put s squared. Then now we multiply. There is an invisible multiplication sign right here. Invisible multiplication sign right here. So after that, we multiply. We say x squared times x. It gives us x cubed. X squared times 1, it gives us x squared. Then we subtract. So x cubed minus x cubed is 0, right? 0x squared minus x squared. Remember this whole part is 0. So negative times this will give us negative x squared. Can x go into this x squared? Yes. So we continue until this x can no longer go into x squared. So we continue. Remember now we bring the remaining expressions down. So we have 0x plus 1. So x now into this x squared, meaning if x go into this x squared, you have x times x, remember, over x and x cancel, you'll be left with x, right? So it is minus x, because x into this one now, right? Is it minus x? It is minus x squared now, divided by x. So it just be minus x. So minus x times x is minus x squared. Minus x times 1 is minus x. Then we further simplify. Remember, whenever you say 2 goes into 4, it goes there 2 times, right? 2 times 2 is 4. You can draw a line and you subtract, right? That's the same thing we're doing here. You subtract. So negative x squared times, let's say, minus negative x squared, right? This negative times this negative will go to positive. So it will be negative and positive, the signs are different. It means they must go out. Negative times this negative is positive. So now here will be positive x, because this is already 0. So here there will be positive x. We'll bring this plus 1 down. Right? X now into x is just 1. Then you have 1 times x is x. 1 times 1 is positive 1. You subtract. So x minus x is 0. 1 minus 1 is also 0. Right? So the remainder now is 0. So we stop. Now the rule says whenever you divide, when you divide one expression by another, when x cubed plus 1 is being divided by x plus 1, as x is approaching minus 1, the result is just equals to the limit of, it is just like you say the quotient, which is x squared minus x plus 1, plus now the remainder and the divisor. So the remainder, which is 0, divided by the divisor, which is x plus 1. As x now is approaching minus 1. Now because the remainder is 0, so this whole term will go out. You will just have x squared minus x plus 1. So you replace this x now with minus 1. So you have minus 1 raised to the second power minus this x now is minus 1 plus 1. So now what happens? This is now positive 1. Negative times negative is positive 1 and then plus 1. So this is equals to 3. So you know that it's confirmed, right? That this was 3. I'll check the problem. Now, so we solved the last one, and then the rest of the other problems now will be left for you to practice. So, question 8 says, the limit of x cubed plus 3x squared minus 6x plus 2 divided by x cubed plus 3x squared minus 3x minus 1. So, we look at this problem carefully, and then if we were asked to factorize, we have a 4-term expression in the numerator and a 4-term expression within the denominator. So one of the ways in which we can think of factorizing it is to use the factoring by grouping method. Can we factorize a numerator by grouping? If we keenly look into the numerator expression, we group the first 2 terms. So we group the first two terms and group the next two terms, we understand that we cannot get a common factor because here all positive and here one negative, one positive. So we cannot get a common factor, right? So we think of another method of which we can factorize our problem. So another method is the syntactic division. Now, so let's use the syntactic division. Another method will be the long division. We'll also use the long division. So let's use the syntactic division. Now, the syntactic division, we deal with the coefficient because what we are finding the coefficient of the expansion. So we deal with the coefficient. Now, what is the coefficient of this x cubed? The coefficient of this one, the coefficient of this one, the coefficient of this two. So each of them, right, let's bring the terms down first. So we have x cubed plus 3 s squared minus 6x plus 2. So all of those ones that are wrote in red are all the coefficients. So we want to write the coefficients down, right? We have 1, we have 3, we have minus 6, and we have 2. The next thing, the constant term, this one, this 2. We've checked all of the factors of 2. We know that 2 has exactly 2 factors, 2 and 1. We check the factors of 2 to see as to whether if we use 2, if we say x is equals to any of the factors of 2, as to whether we're going to get a 0 at the end to eliminate this constant term and make this the next term the new constant term. So let's say x is equals to 1. We take the first one, right? Or we say x is equals to 2. Let's assume x is equals to 2. We start by bringing this first term coefficient down, 1. Then we multiply. It's like multiplying, adding. 2 times 1 is 2, right? 3 plus 2 is 5. 2 times 5 is 10. Negative 6 plus 10 is 4, positive 4. 2 times 4 is 8. 2 and 8 is 10. We cannot get 0 in. So we say we cannot use positive 2. Now we can also say let's use the opposite of positive 2. So we use negative 2. So we bring this 1 down. Negative 2 times 1 is minus 2. 3 times 3 minus 2 is positive 1. Minus 2 times 1 is minus 2. Minus 6 minus 2 is minus 8. Minus 2 times 8 is 16. And then 2 and 16, it cannot give us 0, right? So we erase it. We move to the next factor, which is 1. So we say, what if s is equals to 1? Bring this 1 down, right? 1 times 1 is 1. 3 plus 1 is now 4. 1 times 4 is 4. Negative 6 plus 4 is negative 2. 1 times negative 2 is negative 2. 2 minus 2 is 0. Now, because this x is equal to 1 took our constant term to 0, we now consider this to be one of the factors. So if x is equal to 0, it means we can send this 1 across. It will be x minus 1. Right? Times. Now, we have the new expression. Now, normally, whenever you apply the syntactic, the power will reduce. It will drop from s cubed. It will drop. Right? So, x cubed now, we cannot say the first one will be x cubed. The first one will be x squared. Now, so there is a constant term. There is a new constant term. This x to the first power. This x to the second power. So it normally drops by 1. Now, so let's go now. This x to the second power, right? The coefficient is 1. These are all the coefficients. Plus, because this 4 is positive, 4x to the first power, then minus 2. So you see that we have now factorized the numerator. So now we consider the factor. We say the limit of the numerator now is x minus 1 times x squared plus 4x minus 2. That's the numerator, right? Now let's see the denominator. So I'm erasing. Let's see the denominator expression also. Whether we can factorize it. So again, we apply the synthetic division. We have 1, we got 3, we got -3, and we got -1. So now this is 1x cubed plus 3x squared minus 3x minus 1. So where all of these coefficients is 1, this is 3, this is minus 3, and this is minus 1. So for this one now, we want to know the factors of this one that when we use, we're going to get 0 down here. So 1 just have a single factor 1. So we have, say s is equals to 1. So we drop this 1. And then we say 1 times 1 now is 1. 3 plus 1 is 4. 1 times 4 is 4. Minus 3 plus 4 is positive 1. 1 times 1 is positive 1. Negative 1 plus 1 equals 0. So therefore, we can consider this as one of the factors. So we send this 1 across, it becomes x minus 1 times. So these are our next 3 terms. This is the coefficient of the first term, which is x squared, plus the coefficient of the second one, which is x plus 1. So down here we have x minus 1 times x squared plus 4x plus 1. As x now is approaching -1. So you see, what was allowing the denominator to go to 0 has now been exposed. Because look here, if we were to just use direct substitution, right? If we put 1 there is 1 cubed plus 3 times 1 squared minus 3 times 1 minus 1. So this is just 1 plus 3 minus 1. Then this cancel, then this cancel. So you see that? So we cannot use direct substitution. So that was the reason why we use this one. So what happens? X minus 1 and x minus 1, they cancel. So we now have the limit of x squared plus 4x minus 2 all over x squared plus 4x plus 1. Now before we go any further, x is positive 1, right? Okay. Before we go any further, let's apply the limit within the denominator, right? So if we apply the limit within this denominator here, we put 1 here, this is 1 squared plus 4 times 1 plus 1. 1 plus 4 plus 1. This just equals to 6. So we cannot get 0 within the denominator any longer. So at this stage, we apply the limit. So if we apply the limit now, you have 1 squared plus 4 times 1 minus 2 all over 1 squared plus 4 times 1 plus 2 plus 1 now. So 1 times 1 is 1, 4 times 1 is just 4, minus 2 is just divided by 1 plus 4 plus 1. So 1 plus 4 now is 5, 5 minus 2 is 3, and then 1 plus 4 is 5 plus 1 is 6. 3 into 8 is 1 times, 3 into 6, 2 times. So we just have 1 over 2. So 1 over 2 is our answer, right?